Welcome to Introduction to Building Codes, Bangladesh National Building Code 2020, referred to as BNBC 2020. Part 8 Building Services, Chapter 4 Lifts, Escalators, and Moving Walks. The description of this course is designed to familiarize and assist code officials in locating, describing, and applying the applicable code requirements of the BNBC 2020, Part 8 Building Services, Chapter 4, titled Lifts, Escalators, and Moving Walks Requirements. Our course overview. Internationally, code officials recognize the need for a modern, up-to-date code that addresses the design and installation of lifts, escalators, and moving walks through requirements emphasizing performance. This presentation will cover key topics of the following areas. We will discuss purpose, scope, and terminology related to lifts, escalators, and moving walks, preliminary design particulars, essential requirements for lifts, related codes and standards, design requirements with examples, inspection and certification, along with maintenance and operation procedures for lifts, escalators, and moving walk systems. The goal of this training is for you to learn and apply key code requirements contained in Chapter 4, titled Lifts, Escalators, and Moving Walks, to enhance your performance while reviewing construction documents and inspecting conveying systems. This training will also provide participants with specific examples related to design and installation of conveying systems to further enhance your knowledge of conveying system-related construction. Our course objective. Upon completion, participants will be better able to locate general topics in Chapter 4, Lifts, Escalators, and Moving Walks, understand when a specific conveying system is required, locate applicable tables in related codes and standards for specific situations, apply code requirements to real-world situations, and explain the intent behind a given code requirement. Chapter 4, Section 4.1.1, titled Purpose. The purpose of this chapter is to provide minimum standards for regulating and controlling design, construction, installation, quality of materials, location, operation, maintenance, and use of lifts, escalators, and moving walks to ensure the public safety and welfare. Lifts, escalators, and moving walks code cannot be effective without adequate provisions for its administration and enforcement. The official has the responsibility for establishing that lifts, escalators, and moving walks are designed and constructed to be reasonably free from hazards associated with the presence and use of mechanical equipment, appliances, and systems. We must always think safety first. Section 4.1.2, Scope. Specifically in Section 4.1.2.1, the provisions of this chapter shall apply to the erection, installation, alteration, repair, location, replacement, addition to, operation, and maintenance of lifts, escalators, and moving walks. This section lays out specific requirements for these systems. Section 4.1.2.2 Additions, alterations, repairs, and replacement of equipment or systems shall comply with the provisions for new equipment and systems. This particular section lays out an existing system that we may add on to. We may alter, repair, or replace the equipment that is associated with lifts, escalators, and moving walks. And the driving language of this section indicates that these systems must comply with the new equipment and system requirements of this particular code. Section 4.1.2.3, where in any specific case, different sections of the code specify different materials or other requirements, the more restrictive one shall govern. This is where we understand the limits of safety when we apply the code. Very rarely we have differences in sections. However, when it is discovered based upon an application while the code user is navigating through the code and this happens, again, the more restrictive requirement shall govern. Where there is a conflict between a general requirement and a specific requirement, the specific requirement shall be applicable. Again, the first part of this section describes where there could be dual coverage and states that the most restrictive prevails. The official must carefully evaluate each and every application regarding materials, methods of construction, or other requirements that make decisions that provide the greatest safety. That is our goal here of administering the code. The second part of this section describes if conflicting coverage is encountered, then the specific requirement is to be applicable. Conflicts within the code do not occur often, but if they do, this section applies accordingly. This section provides an alphabetical list of the terms used in and applicable in this chapter of the code. In case of any conflict or contradiction between a definition given in this section and that in Part 1, the meaning provided in this section shall govern for interpretation of the provisions of this chapter. This is very specific in that any definitions are specific to this chapter. A code provision could be misinterpreted if the definition of a term as used in the context of the code is not understood. The following slides will provide key definitions that will assist the code user to properly understand certain terminology related to this chapter. Codes, by their very nature, are technical documents. As such, literally every word, term, and punctuation mark can add to or change the meaning of the intended result. This chapter contains several terms that are important to understand the provisions of this code. Definitions are found both in this chapter and throughout the code. Let's look at some key terminology. Lift is defined as a machine designed to transport persons or materials between two or more levels in a vertical or substantially vertical direction by means of a guided car or platform. The lifting force is provided by electric motor or fluid pressure. The word elevator is also synonymously used for our term lift. A lift, also known as an elevator, is a machine used to transport people or materials between two or more levels as indicated. The key to this section, applying the terminology, is understanding as well the force provided by the system. This is either an electric motor or fluid pressure that provides the power to operate the lift. We commonly find lift locations in buildings and areas of buildings such as hotels, hospitals, office buildings, shopping malls, and other retail stores. Additionally, multifamily apartments are equipped with lifts, airports, and parking garages. Our terminology for escalator: a power-driven, inclined, continuously moving stairway used for carrying passengers from one level to another. Unlike a lift, the rider is not located in a cab or on a platform. A lift tends to ascend or descend vertically, while an escalator travels at an angle of approximately 15 degrees or greater. Handrails and guards are provided for safety of the user. As indicated in the picture below is a description of an escalator. As you will see, it is well equipped with handrails and moving stairs that ascend or descend from one floor level to another. Escalator landing is defined as the portion of the building or structure which is used to receive or discharge passengers into or from an escalator. As indicated in the picture below, we can clearly see the landing that occurs at the end or beginning of the moving stairway that we call an escalator. It is quite evident prior to getting onto the escalator or leaving the escalator. It is the level platform that receives people from the escalator. The other definition is escalator landing zone. This is a space extending from a horizontal plane 40 centimeters below a landing to a plane 40 centimeters above the landing. You may ask yourself, where are some commonly found escalator locations? We find escalators typically in shopping malls and other retail stores that allow the patrons to ascend or descend from different floor elevations readily without taking a vertical lift. Airports, rail and subway stations, along with museums are other locations that we may find escalator locations. Terminology for moving walk: a power-driven, horizontal or inclined, continuously moving conveyor used for carrying passengers horizontally or at an incline up to a maximum of 15 degrees. As seen in the picture below, there is a moving walk. This is where people enter the walk. It is essentially a conveyor that moves people from one point to another, typically horizontally, but it can also be inclined to a maximum of 15 degrees. We commonly find moving walk locations in airports, rail and subway stations. This is where we have very long horizontal distances to have people traverse from one point to another that could be very long distances. We want to provide a means to allow people to get there without much effort. Thus, we find moving walks tend to be utilized less than lifts and escalators. However, they're found more frequently in public transportation areas like airport concourses, long rail and subway stations, to allow for the movement of people readily from one point to the other. Chapter 4, Section 4.1.4, titled Preliminary Design Particulars, gives us the preliminary design requirements that must take place. Specifically, Section 4.1.4.1 indicates all relevant aspects of lift, escalator, or moving walk installations shall be properly evaluated during the planning stage of the building in order to design the most effective conveying system. This is laying out a requirement that an analysis may need to take place to provide the most effective conveying system, such as maybe vertical lifts in certain locations, moving walks for long horizontal areas, or escalators typically used in retail establishments, as well as planning the area out for these machines to be installed, not only structurally, but mechanically and electrically as well. Section 4.1.4.2 lays out appropriate steps shall be taken during the planning stage of the building to determine particulars of lift, escalator, or moving walk and the necessary provisions to be kept in the building structure, so as to meet the requirement of this code. Additionally, discussion shall be carried out during planning stage with all concerned parties, such as the building owner, architect, consulting engineer, and or lift, escalator, moving walk manufacturer, to determine the extent of necessary provisions to be kept in the building. The code recognizes that for any project or a portion of the project to be successful and code compliant, a detailed preliminary design that involves all stakeholders is an important step. Within Section 4.1.4.7, the building plans submitted with the application for seeking permission of installation of lift, escalator, or moving walk from the authority shall include a layout of the lift, the escalator, or moving walk, properly identified in the drawing along with the detailed particulars as per Appendix L. As indicated, there is a direct reference to Appendix L to be submitted with the drawings and other construction documents. Section 4.1.4.8 indicates that specifications for lifts, escalators, and moving walks shall include detailed particulars as per Appendix L. As an example, Appendix L contains particulars of lifts, escalators, and moving walks that needs to be filled out by the applicant and submitted to the authority with the construction documents for these conveying systems. As can be seen here, this is a format for particulars regarding lifts, escalators, and moving walks. The lift category indicates several items that must be indicated, such as number of lifts required, rated speed, travel height, just to name a few, including the type of drive system indicated in item K. The pit depth is important as well. That needs to be indicated in item O, as well as particulars of ventilation of the car in item U, particulars of control buttons in the car, the position indicators in the car, as well as the call buttons in the landing, and the electric supply requirements, power requirements in volts, either AC or DC, the phase, the hertz, which is cycles per second, type of wiring system, as well as the lighting is so important. The escalator category. We must indicate the number of escalators required, the capacity of each escalator, number of people per hour, the rated speed in meters per second, the travel height in meters, the travel length as well, the width of the escalator. In item F, specifically, construction, design, and finish of balustrade. We need details of the steps to make sure the steps are according to the code requirements, as well as the materials of the landing plate. And just like the lift category, the electrical supply needs to be documented. Again, the voltage, the type of system, whether it's alternating current or direct current system, the phase of the system, as well as the hertz or cycles per second, and any additional requirements. When we get to the moving walk category, we will be filling out the number of moving walks required, as well as the capacity of each moving walk. Again, rated speed. D gives us the inclination in degrees as well. This is important because we do not want to exceed what the code allows for the degrees above the horizontal plane for moving walks. The width of the moving walk is important as well because the width is a function of how many people that the moving walk can carry, as well as the construction, design, and finish of balustrade. Material of the landing plate is typical that we find in the other categories, as well as the electric supply again, and any additional requirements. The format for particulars indicated in Appendix L gives a nice checklist for the applicant to make sure that they have included many of the required particulars along with their construction documents for review and approval by the authority. Section 4.2, titled Essential Requirements for Lifts, gives us very specific requirements for lifts and the installation and construction requirements of these particular lifts. Section 4.2.1.1 indicates that lifts are required in buildings more than 6 stories or 20 meters in height. The code, however, does not prohibit utilizing a lift in situations less than these minimums. So it is up to the designer and the owner of the building whether to install a lift in lower story buildings. Section 4.2.1.2, Item A. When passenger lifts are installed in any building having more than 10 stories or of a height more than 32 meters, each floor served by these lifts must have access to at least one lift with a stretcher facility in accordance with Section 4.2.1.2b. Note to the code user, per Section 4.2.1.2 Item C, multi-story hospitals or care buildings shall have at least one hospital lift with a stretcher facility. This clearly lays out the requirement for stretcher facilities that are required in buildings as well as multi-story hospitals. Section 4.2.1.2, item B, gives us specific dimensions regarding stretcher facility. A stretcher facility or lift car shall accommodate a raised stretcher with the patient lying on it horizontally by providing a minimum inside platform area. Dimensions are indicated of 1,275 millimeter wide by 2,000 millimeters long, with a clear opening width of 1,050 millimeters. Unless otherwise designed to provide an equivalent facility to allow entrance and exit of an ambulance stretcher. As you can see, the minimum of the ambulance stretcher is 600 millimeters by 2,000 millimeters long. These lifts shall be identified by the internationally recognized symbol for emergency medical services. As indicated in the graphic, we can see the minimum interior dimensions that must be maintained when a stretcher facility is required for the lift car. The function is to, of course, aid first responders, nurses, or doctors in transporting an injured person on a stretcher between floors. The minimum dimensions are provided to accommodate a stretcher to the floor. Section 4.2.1.3, item A. One or more lifts shall be provided with standby power in a building that has more than 10 stories or a height of more than 32 meters. Hospital and healthcare buildings are also required to provide standby power. This is essential due to the fact that the story or height of the building is now getting quite high, and as well as hospital and healthcare buildings need this essential power to be provided in these particular buildings. Item B of section 4.2.1.3 tells us that standby power shall be provided by an approved self-contained generator set to operate automatically whenever there is a disruption of electrical power supply to the building. And again, once a building exceeds 10 stories or 32 meters in height, or in a hospital or healthcare buildings, an automatically operated generator is required to provide power to at least one of the lifts provided in the event of a loss of electrical power to the building. The operation of the standby power system is specifically indicated here for the number of seconds that the generator must supply power. Item number 1 of section 4.2.1.3c tells us that where only one lift is installed, the lift shall transfer to standby power within 60 seconds after failure of normal power. Item 2 is where we have 2 or more lifts that are controlled by a common operating system. All lifts in this case may be transferred to standby power within 60 seconds after failure of normal power. Or, if the standby power source is of insufficient capacity to operate all lifts at the same time, all lifts shall be transferred to standby power in sequence, thus lessening the initial load on the system. After all lifts have been returned to the designated landing, at least one lift shall remain operable from the standby power. This section gives us very specific limitations for buildings with one lift or buildings with multiple lift and the associated time limitation that the standby power must be supplied to the system on a normal power failure. Section 4.2.1.4 item A gives us a reference regarding lifts. At least one of the lifts of any lift bank shall have features as per requirements of ADA accessibility guidelines. Item B of this section further tells us about this ADA accessibility guideline, and so states that accessible lifts shall be on an accessible route and shall comply with the ASME A17.1, the 1990 edition of the Safety Code for Elevators and Escalators. The American with Disabilities Act guidelines will give us very particular information about the features regarding the lift that must be accessible. As indicated in the previous slide, the reference was with the ADA. This is the American with Disabilities Act. It was signed into law in the United States of America on July 26, 1990. The ADA prohibits discrimination against people with disabilities and guarantees them the same opportunities as everyone else to participate in mainstream life. As this is associated with our buildings, and specifically the requirement for lifts when applicable, we must provide equal opportunity for people that are disabled to function and get around our buildings just like everyone else, to circulate accordingly from one floor level to another and access different parts of the building easily according to the accessibility guidelines. A partial list of lift features is indicated here regarding the reference to the ADA requirements for an approved type of lift. This partial list contains push button, either raised or flush, their minimum and maximum height above the floor, and minimum size in their smallest dimension. This requirement allows a person with a disability, perhaps in a wheelchair, the dimensions above the finished floor to reach the push buttons and actuate these buttons accordingly. Self-leveling features are indicated, as well as audible signal or verbal enunciators for up or down, indicating automatic open and close doors with stop and reopen devices if doors become obstructed by a person, as well as the minimum time lift doors remain fully open, and the minimum time until the car doors start to close. These are critical settings that must be provided in the installation. Level of illumination at car controls, platform, and car threshold and the landing sill are key to providing sight and illumination for the passengers accordingly. Tactile, braille, and visual control indicators are also indicated in this particular section. And again, this is just a partial list of the lift features. The code user is directed to this section for all of the particulars regarding the approved type of lift referencing the ADA. Responsibility of the owner is given here in section 4.2.1.5, item A. It is the responsibility of the owner of the premises where the lift will be installed to obtain necessary permission from the authority before the erection of lift or lifts and for subsequent commissioning and operation of lifts. In item B, the owner shall conduct periodic inspection and maintenance indicating the installation in safe working condition at all times. These sections establish the party responsible for obtaining permission and inspections regarding installations of lifts, and that is primarily the owner of the particular building where these will be installed. We have reference standards. Section 4.2.1.7 for detailed specifications of lifts, escalators, and moving walks, reference shall be made to the latest edition of the ANSI ASME A17.1 or European EN 81 code. These codes will provide a much more detailed set of specifications and specifics for lifts, escalators, and moving walks than covered in the code. This is where we get more specific with the mechanical and the electrical and many other dimensions regarding the design and installation of lifts, escalators, and moving walks. Safety considerations is indicated in section 4.2.2. As we move through this particular section to item B of section 4.2.2.1, there is a requirement that lift well enclosures and machine rooms shall be constructed with fire-resistant materials. In case of fire, the lift well enclosure shall not give off harmful gas or fumes. A lift enclosure directly connects stories of a building and would provide a direct path for fire to spread. That's why we have this section here to be made of fire-resistant materials when it comes to lift well enclosures and machine rooms. Examples of fire-resistant materials that are commonly used to construct a lift enclosure include masonry block and reinforced concrete. This requirement serves multiple purposes, including allowing and protecting emergency personnel utilizing the elevator for rescue operations. Section 4.2.2.3. For buildings having height of 15 meters or more, at least one lift shall meet the requirements of fireman's lift as described below. The following indicates specific requirements for the fireman's lift. Item A. Lift car shall have a floor area of not less than 1.44 square meters. It shall also have a loading capacity of not less than 544 kilograms, approximately 8 persons. B. Lift landing door shall have a minimum fire resistance of 2 hours. Item C. Door shall be of automatic operation for car and landing. And finally, item D. The lift speed shall be 1 meter per second or more so as to reach the top floor from the ground within 60 seconds. Again, this is specific requirements for the fireman's lift. Warning signs are given specifically in section 4.2.2.4. The warning signs against use of lifts during a fire shall be displayed near every call button for passenger lifts in accordance with 4.2.10.3. As seen here, the warning sign indicates do not use lifts if there is a fire. Emergency evacuation system in section 4.2.2.8 indicates there shall have arrangement for emergency unlocking of the landing and lift door with a special key from any landing for evacuation as well as for maintenance. When fire departments and other emergency response agencies respond to emergencies, their ability to quickly access the location of the emergency can be the deciding factor of a successful response. This code section is very specific in that it requires a special key to unlock and control any of the lift door on each and every floor. Even when emergency responders are provided the necessary keys, the correct key may have to be identified from a large collection of keys for any one building. As seen in the graphic, there is a marking directly on the key ring that indicates emergency elevator key, danger, for use by authorized persons only. As an example, an elevator key is an important tool to firefighters. The key allows firefighters to access the interior of the shaft housing an elevator cabin to initiate rescue in case of a malfunction or the loss of building power, just to name a few. Lift door safety requirements are indicated in section 4.2.3.9. Item A requires that car and landing doors shall open and close in full synchronization, being mechanically connected to each other. B, the doors closed by automatic means shall be provided with door reopening devices, which will function to stop and reopen a car door and adjacent landing door in case the car door is obstructed while closing. The reopening device shall also be capable of sensing an object or person in the path of a closing door without requiring contact for activation. Door reopening devices shall remain effective for a period of not less than 20 seconds. The operating mechanism of car door shall not exert a force of more than 125 newtons. Finally, item C, car doors shall be equipped with efficient interlocking or other devices so that the door cannot be opened except when the lift car is at the landing, and that the lift car cannot be moved away from the landing until the leading edge of the single slide or double speed door is within 50 millimeters of the nearest face of the door jamb, or the leading edges of the center opening doors are within 50 millimeters of contact of each other. These three important key areas make certain that the installer and manufacturer must provide these safeties regarding lift door and lift door assemblies. Car operating panels are required to provide certain specific requirements as indicated in section 4.2.3.14. Car operating panels shall be conveniently located on the side near the door so that the passengers can register calls as quickly as possible. The center line of the alarm button and emergency stop switch shall be at a nominal height of 890 millimeters, and the highest floor button can be no higher than 1.37 meters from the floor. Floor registration buttons, exclusive of border, shall be a minimum of 18 millimeters in size. Raised, flush, or recessed. Visual indication shall be provided to show each call registered and extinguished when the call is answered. The depth of flush or recess buttons when operated shall not exceed 10 millimeters. Markings shall be adjacent to the controls on a contrasting color background to the left of the controls. Letters or numbers shall be a minimum of 15 millimeters high and raised or recessed 0.75 millimeter. Sign plates permanently attached shall be acceptable. And last, emergency control shall be grouped together at the bottom of the panel. As seen in the picture below, we have the emergency controls indicated together at the bottom of the panel. The left button is an alarm button down at the lower left-hand portion of the picture, and on the right-hand side, adjacent to the alarm button, is the emergency stop button. Another section, Section 4.2.3.15, gives the requirement as a suitable battery-operated alarm system shall be installed inside the lift car so as to raise an alarm at a convenient place for getting assistance for passengers trapped inside the lift car. These two sections provide requirements for the car operating panels. Our next section, 4.2.9, covers hall buttons, hall lanterns, and special signs. Regarding hall buttons, section 4.2.9.1, item A, indicates that each landing shall have hall call buttons to register call for lift service for upward or downward movements. The center line of the hall call buttons shall be at a nominal height of 1 meter above the floor. This is a very specific measurement that must be complied with. Item B, direction buttons, exclusive of borders, shall be a minimum of 18 millimeters in size. Raised, flush, or recessed is acceptable according to this section of the code. Visual indication shall be provided to show each call registered and extinguished when the call is answered. Depth of flush or recess button when operated shall not exceed 10 millimeters. Again, we see some specific dimensions regarding direction buttons and the distance from finished floor that the hall call buttons must be installed according to this particular area of our code. The next section, titled Hall Lanterns, is given to us specifically in section 4.2.9.2. Item A indicates where lifts are installed in totally enclosed wells, a visual signal shall be provided at each lift well entrance, indicating to the prospective passenger car answering the call and its direction of travel. An audible signal may also be included. B, the visual signal may be in the form of digital lift position, indicator, or directional indicator. The visual signal for each direction lift position shall be a minimum of 62 millimeters in size and visible from the proximity of the hall call buttons. Last, the center line of the fixture shall be located at a minimum of 1.8 meters from the floor. These three specific sections give us the requirements for hall lanterns. As indicated in the picture below, we have a directional indicator that is indicated and so mounted above the 1.8 meter dimension from the floor, as well as providing illumination for people to see in the local area that is adjacent to the hall call buttons. Special signage in section 4.2.9.3, item C. A permanent warning sign shall be installed immediately above each hall push-button station on each floor, reading, "In fire emergency, do not use lift. Use exit stairs." This sign shall be in letters not less than 12 millimeters in height. Now, in a fire emergency, an occupant will normally try to exit the building by the route he or she entered, such as the elevators. The permanent warning sign will indicate that the occupants not use the elevators, but rather use the exit stairways to exit the building. The graphic indicated in the slide shows the signage directly above the push-button station, indicating in very bold letters, not less than 12 millimeters in height, stating, "In fire emergency, do not use lift, use exit stairs." This is the location that it needs to be installed, so the occupants can clearly see the instructions in case of an emergency. Safety considerations is continued by means of section 4.2.3.1. A requirement that references a table regarding various rated loads is given to us here. Lift cars shall have net maximum inside area for different loading capacities as shown in table 8.4.1. As we look at the table below, the first column indicates the rated load in mass, kilograms. The next column is the maximum available car area in square meters. And the third column indicates the maximum number of passengers accordingly. Now, there are notes to the table that are indicated in the bottom of the table that are a function of the table. As an example, if we have a rated load of 525 kilograms, the next column over to the right-hand side will give us the maximum available car area. In this case, would be 1.45 square meters. And the maximum number of passengers accommodating that particular area would be 7. As you can see, as the rated load increases, the maximum available car area increases, and so does the maximum number of passengers. Section 4.3, titled Design Considerations. The number of lifts, car capacity, and speed of the lift shall be selected to have the most effective lift system. The lift system shall be able to handle adequate number of passengers during peak hours and at the same time interval, and travel time shall be within reasonable limits. Section 4.3.1.2 indicates that average interval shall not be more than shown in Table 8.4.7. Travel time shall not exceed 150 seconds. In this section, it begins to lay out a reference in the form of Table 8.4.7 that we will look at, and a maximum travel time not to exceed 150 seconds. The next section is called Handling Capacity. It is section 4.3.1.3 that reads, the passenger handling capacity that we note as H of a lift system for different occupancies in terms of the number of passengers to be handled in the building in a 5-minute peak period shall not be less than that indicated in Table 8.4.7. Again, another reference to Table 8.4.7. Table 8.4.7, titled Recommended Interval and 5-Minute Handling Capacity for Different Occupancy. Within the table, we have 3 distinct columns. The first column is the type of occupancy. As you can see, we have categories: office category, hotels and motels category, apartments, and hospitals are the categories. Within the categories are the specific uses of these particular categories. For office, indicating diversified tenancy, high quality, standard quality. Single tenancy, high quality, standard quality. When we get into the motels or hotels as well, we have high quality and standard quality. Apartments that we use as residents are split up into high-cost apartments, middle-income apartments, low-income apartments, and finally dormitories and halls of residence. The hospital category provides us with private hospital, general hospital, long-term nursing facilities, educational institutions, buildings with assembly facilities, shops, and stores. The second column gives us our interval in seconds that ranges depending on the category and specifics within that category. The third column gives us the 5-minute handling capacity, H, in percentage. And as you can see, the handling capacity differs with respect to each category and subcategory within each main category. Section 4.3, Design Considerations. For the purpose of population estimation, we look to Section 4.3.1.4. The density of people shall be based on the actual number of occupants, but in no case less than those specified in Table 8.4.8. The occupant load of mezzanine floor shall be taken into account for working out the population for a particular floor to which the mezzanine floor discharges its load. As indicated in this section, we are given a reference to Table 8.4.2 as far as the number of occupants related to this particular design consideration. Table 8.4.8, titled Occupant Load for Estimation of Population, is given here. The first column again gives us the categories. The second column in this table gives us the population factor as a number in square meters for the net usable area per person in the office category. If you are in the motels and hotels category, you are given a value of 1.3 people per room for high-quality hotels and motels, 1.7 people per bedroom for standard quality, and 1.9 people per bedroom for conventions. And as you can see, the category apartments, hospitals, buildings with assembly facilities are also given as well with the population factors for those particular areas within buildings. Section 4.3.1.6, Item A, the handling capacity for incoming up-peak passenger shall be calculated by the following formula. H equals 300 times Q times N times 100 divided by P times T, where H is the passenger handling capacity of the lift system during 5-minute peak period, expressed as a percentage of population handled. Q is the average number of passengers in each car per trip, 80% car capacity. N is the number of lifts in the system, where P is the total population to be handled during peak period. The final variable T is the average round trip time in seconds. That is, average time required by each lift taking one full load of passengers from ground floor, discharging them in various upper floors, and coming back to ground floor for taking fresh passengers for next trip. Continuing with section 4.3.1.6a, the average interval shall be calculated by the following formula. I equals T divided by N, where I is the interval of availability of lifts on the lowest lift lobby. N is the number of lifts in the system. T, again, is the average round-trip time in seconds. That is, again, the average time required by each lift, taking one full load of passengers from ground floor, discharging them in various upper floors, and coming back to ground floor for taking fresh passengers for the next trip. As you can see, we will solve for the interval of availability of lifts on the lowest lift lobby, variable I. Now let's utilize these equations and tables to solve an example problem. An example is given to us here. How many lifts are needed to provide an acceptable level of service for a high-quality hotel, given the hotel is 8 stories in height, 40 sleeping rooms per story, number of passengers carried in a lift per car trip, Q equals 10, average round trip T equals 86 seconds. Try one lift. Check if the average interval I is within interval according to table 8.4.7. So we start out with the equation I equals T divided by N. I, of course, in this case, equals 86 seconds. Divided by one lift, again, would equal 86 seconds. We now need to compare this value in our given design to the range that is allowable in Table 8.4.7. Utilizing Table 8.4.7, we find the type of occupancy. It is a hotel in our given application of high quality. The interval in seconds ranges between 30 to 50 seconds. Therefore, our initial interval of 86 seconds will not comply with what we have applicable in the table. As you can see, I, at a value of 86 seconds, is greater than the maximum allowable 50 seconds indicated in the table. We could now try 2 lifts. So we simply recalculate the interval. I equals 86 seconds divided by 2 lifts, which equates to 43 seconds. Now we fall within the range of 30 to 50 seconds that is given to us in the table for a hotel of a high quality as indicated in Table 8.4.7. This is the first piece, and we will continue our design example. Next, with an acceptable interval, let's verify the handling capacity is within the acceptable range. For this, we'll need to calculate the total population handled in the peak period. Let's take a look at Table 8.4.8 again. This table, again titled Occupant Load for Estimation of Population, gives us the type of occupancy and the population factor. For our example, an application, we have a hotel of high quality. The population factor given to us from this table is 1.3 people per room. We can now utilize this particular factor and calculate the total population. We will continue this example. With the information indicated in the beginning of our example, we have 40 rooms per story, and we have 8 stories that make up our high-quality hotel. By having 40 rooms per story times 8 stories, we have a total of 320 rooms that is calculated. For the population, we take 320 rooms and multiply it times the factor that we found in Table 8.4.8. We multiply the rooms times this factor, and this allows us to equate 416 people as total population. Let's take this population value and calculate the handling capacity by using the formula given in section 4.3.1.6 item A as follows. Again, the formula is going to give us a solution in percentage for the 5-minute peak capacity. The formula again is 300 times Q times N times 100 divided by P times T. And again, we have the explanation of what these variables in our solution should provide us. Continuing our example, we will now input the variables. We solve this equation as H equals 300 times 0.8 times 10 times 2 would be the N variable times 100. We simply divide that by 416, which is our total population, times 86, resulting in our solution of 13.4%. Next, we must check this percentage with the allowable values in Table 8.4.7. Referencing Table 8.4.7, the type of occupancy column we follow to the hotels of high quality, and we move to the third column, which gives us the 5-minute handling capacity in percentage. The range for a high-quality hotel is given to us between 12 and 15%. Our calculation resulted in 13.4%, which falls within 12 to 15% range according to Table 8.4.7. Therefore, our solution is for 2 lifts with a car capacity of 10 would satisfy the recommendations in the code. It should be noted that this is a solution. Other solutions that may involve a different travel time, quantity of lifts, car size, etc., would be acceptable as well. Section 4.3.3.3, item B, the lift lobby in front of lifts shall be wide enough to allow sufficient space for waiting passengers and proper vision of the hall call button and the hall lanterns. Figures 8.4.2 to 8.4.6 give acceptable arrangements of lifts in a group with acceptable space for waiting passengers. More space shall be allowed in front of the lifts in the main floor than upper floors. It should be noted that it is preferable that the lift lobby is not used as a thoroughfare as well. But when absolutely needed, the lift lobby shall be wide enough to take into account the space for people who are moving. The code provides a general layout of multiple lift configurations. Here are the options for a 2-lift layout. Notice the passenger waiting space is a function of the car depth. In Figure 8.4.2, the 2-car arrangement, we have 2 different arrangements. The first arrangement, on the left-hand side, gives us 2 lifts that are side by side. In front of the lifts is the passenger waiting space. The width or minimum distance measured from the lift to the wall is a function of the car depth. The car depth is given to us as A, therefore the minimum distance must be the depth of the car in this arrangement. The arrangement to the right shows two lifts, one in front of the other, is given to us at 1.5 times the depth of the car to 2 times the depth of the car, which is given as the dimension A in this particular situation. This would drive the minimum distance between the lifts for the passenger waiting space. An example of a 3-car arrangement is given in figure 8.4.3. Again, on the left-hand side, we have the arrangement of lifts that are side by side. The passenger waiting space must be a minimum of 1.5 times the depth of the lift car, but it must be a minimum of 1.8 meters at the least. The arrangement to the right, the distance between lifts, as shown, is 1.5 times the depth of the car to 2 times the depth of the car. This is the minimum that can possibly be for the 3-car arrangement. 4-car arrangement is given to us in figure 8.4.4. In this case, we have 4 lifts that are installed side by side. The passenger waiting space in this arrangement is a function again of the car depth. We need to be 1.5 times the car depth, or a minimum of 2.4 meters in distance for the passenger waiting space, as indicated in this arrangement. The 8-car arrangement is given to us in figure 8.4.6. We can see the passenger waiting space between the lifts. It is still a function of the car depth, and it must be 2 times the dimension of the car depth. However, the space must be open at both ends in the passenger waiting space. Section 4.4, Escalators. Noticing the picture below, we have an escalator, and certain components are well defined as terminology in our code. We have the landing plate starting from the top, the comb plate, the escalator step or the tread, and the handrail indicated on the right side. Moving to the left side, we have the skirt, the balustrade, and the newel. Many of these components are similar to the components on moving walks. An escalator is defined as a power-driven, inclined, continuously moving stairway used for carrying passengers from one level to another. The balustrade is considered a row of balusters meant for supporting moving handrails. The comb plate is a pronged plate that forms part of an escalator landing and engages with the cleats of the steps or treadway at the limits of travel. Last, the landing plate is considered the portion of the building or structure which is used to receive or discharge passengers into or from an escalator. This gives us a clear vision of the components that make up escalators. A note to the code user: there are no specific requirements or thresholds in the code that will require the installation of an escalator. All escalators are optional. However, if one is installed, it shall meet the applicable code requirements. Unlike lifts, there are no specific requirements that will require, again, the installation of escalators. Escalators are optional. And again, if in fact one is proposed to be installed, then it needs to meet the requirements, as well as all of the approvals needed by the authority and certifications, things of that. The main line of circulation is given to us here as a requirement based upon section 4.4.1.1. This section explains that escalators shall be located in the main line of circulation and in such a way that most persons entering the building can see it. This way it's available for use to the people that come into the building upon viewing where the escalator is. Further, this section indicates that care shall be taken to eliminate interference to traffic movement. Now, the next section is a directional requirement. Section 4.4.1.4 gives us the requirement that the escalator shall have provisions to run in both upward and downward directions. However, it shall not run in one direction for one trip and reverse for the next. Starting, stopping, or reversal shall be controlled only by an attendant, and with the assurance that no passenger is riding at that time. This is a safety precaution, and if the escalator will run in a different direction, it must be controlled by an attendant. Accessibility comes in our code requirement. According to section 4.4.1.6, near the place of escalator installation, one lift with a wheelchair facility shall be installed to facilitate vertical movement of disabled persons. Now, this is necessary due to the fact that wheelchairs cannot function on an escalator. They are not permitted to ride on an escalator or be transported on an escalator. Therefore, this section is very specific and indicates that a lift is necessary for a wheelchair facility designed to vertically lift disabled persons from each level where an escalator is present. Therefore, we are including people with disabilities to circulate just as people without disabilities in our buildings and different areas of buildings that are so equipped with escalators. Section 4.4.2.1, the angle of incline of the escalator shall not be more than 30 degrees from the horizontal. In particular cases, an angle of incline up to 35 may be permitted for escalators having a vertical rise of not more than 6 meters. Handrails and balustrades, two important components when we speak and understand the requirements for escalators. The handrail is a function of providing stability for people that are traversing on the escalator, as well as the balustrade to provide a nice smooth surface and protection for the people as well. We have specific requirements, one being section 4.4.2.3a, escalators shall be provided on each side with solid balustrades. On the step side, the interior panel, the balustrade shall be smooth and substantially flush, except for protective molding parallel to the run of the steps. Vertical moldings that cover joints of panels shall be properly beveled and shall not project more than 6.5 millimeters. Gaps between interior panels of the balustrade shall not be wider than 4 millimeters. Each balustrade shall be provided with a handrail moving the direction in the same direction at the same speed as the step. This will allow the riders to adequately grasp the handrail and become stable. This section is also indicating that the handrail, while moving, must be moving at the same speed as the step, so there is either no lag or forward movement that would cause the people to lose their balance. The depth of treads and the rise between the treads are given to us in section 4.4.2.7 item A. This requirement allows us to understand the design for escalator stairs. The depth of any step tread in the direction of travel shall not be less than 400 millimeters, and the rise between the treads shall not be more than 220 millimeters. That is our maximum height between treads. We start out looking at the photo below. As indicated, we have a minimum tread depth of 400 millimeters, and we have a maximum rise between the treads not to exceed 220 millimeters. These are our minimum and maximum requirements according to this section regarding the escalator steps. Within section 4.4.2.12, we are given that the rated load in kilograms on an escalator shall be computed by the following formula. The rated load can be equated to what equals 0.27 times the width, which is indicated as W, times A, which is the horizontal distance between the upper and lower plate teeth in meters. The width in the equation is the width between balustrades in millimeters. The rated load is given as a solution in kilograms. The required structural factor of safety for escalator components in 4.4.2.13 is indicated as such. Trusses and structural members including tracks, 5. Drive machine parts, steel or bronze, 8. Cast iron and other materials, 10. Power transmission members, 10. And the safety factor regarding annealed cast steel step chain links is 20. And again, these are the structural factor of safety for escalator components. As an example, we have provided a design example according to the following. Find the minimum rated load of an escalator given. A clear width between balustrades of 800 millimeters, a total vertical rise of 8 meters, an angle of incline of 30 degrees, using the formula. Rated load equals 0.27 times W times A. Our first step is to determine A, given vertical rise and angle of inclination. As seen in the diagram below, we have an angle of incline of 30 degrees. We have a vertical rise given as 8 meters. We need to solve for the horizontal distance. In this case, we will use the tangent of 30 degrees equaling 8 meters divided by A. What we are doing here is taking the tangent of 30 degrees and setting that equal to the rise divided by the run, which we've indicated as the variable A. We can rewrite the equation, solving for A, which is the run, the horizontal distance, equating that to 8 meters, dividing it by the tangent of 30 degrees, that is our angle of incline. Working that out, A, which is the horizontal distance, equates to 13.86 meters. That is our first step. The next step is to substitute A and W into the rated load formula and solve directly. Whereas our rated load formula, as we recall, is 0.27 times W times A. We introduce those values into our rated load formula and set that equal to 0.27 times 800 millimeters times 13.86 meters. Therefore, our rated load equates to 2,994 kilograms. A partial list of safety features according to section 4.4.2.14 is given here. The first item in this partial list is that each escalator shall be provided with an electrically released, mechanically applied brake capable of stopping the up or down traveling escalator with any load up to the rated load. The braking system shall have provisions to bring the escalator automatically to a smooth stop in the event of failure of electric power or mechanical parts. A speed governor shall be provided, the operation of which shall automatically shut down the escalator in case of over or under speed and prevent reversal of direction. This also provides safety as well to the occupants that are riding or traversing on the escalator. Adequate illumination shall be provided at all landings, cone plates, and down all stairways. An emergency stop shall be located near the cone plate in a location that we must see visibly. So we have an example in the picture below of an emergency stop that is in a good location, just in case somebody must push this emergency stop to stop the operation of the escalator in an emergency situation. It must be somewhat accessible to the people. All machinery spaces shall have access doors or panels for inspection that are lockable to prevent unauthorized access. And finally, the last item in our partial list is reasonable ventilation shall be provided in machinery spaces. Section 4.5 contains requirements for moving walks. Moving walks are very similar to escalators. However, an escalator transports people vertically via moving staircase, while a moving walkway transports people horizontally, or at small vertical changes, via a moving walkway. As seen in the photo below, this shows an airport concourse with a horizontal moving walk. This allows people to easily traverse on this moving walkway with little or no effort horizontally to get from a point in location from one point to another. Section 4.5.1.1, angle of incline of moving walk shall be no more than 15 degrees. A moving walk may have a sloping entrance and exit or level entrance and exit. Table 8.4.10, titled Operating Speeds of Moving Walk, is given to us here. The first column of this table gives us the incline of ramp on slope. We have ranges from 0 to 3 degrees, over 3 degrees to 5 degrees, over 5 degrees to 8 degrees, over 8 degrees to 12 degrees, and finally over 12 degrees to 15 degrees in the first column. The second column gives us the maximum speed with level entrance and exit in meters per second, depending upon the incline of the ramp on the slope. The last column gives us the maximum speed with sloping entrance and exit, again in meters per second. We can see the appropriate values for the maximum speed for the sloping entrance and exit. As you can see in Table 8.4.10, which covers the maximum operating speeds based on the slope of the ramp, as the moving walk degree of slope increases, the maximum allowable speed also decreases. This is to ensure adequate level of stability is provided for the passengers. Section 4.5.3, titled Handrails, gives us very specific requirements for moving walks. Section 4.5.3.1 specifically indicates that each balustrade shall be provided with a handrail moving in the same direction and at the same speed as the treadway. Only one handrail may be allowed in a moving walk when the slope of the walkway does not exceed 3 degrees. Operating speed is less than 0.35 meters per second, or the width is no more than 530 millimeters. Section 4.5.3.2 indicates that each moving handrail shall extend at normal handrail height not less than 300 millimeters beyond the line of points of cone plate teeth at the upper and lower landings. As you can see, we have two specific key requirements that are indicated here regarding the number of handrails, the slope not to exceed 3 degrees, operating speed, and the width of the walkway accordingly. Additionally, we have a handrail height to be not less than 300 millimeters beyond the line of points regarding the comb plate teeth and at the upper and lower landings. A partial list of safety features according to sections 4.5.2 through 4.5.6 is indicated below. The partial list includes balustrades that are required on each side and the width between them at a point 680 millimeters vertically above the tread, way that not be less than the width of the tread nor exceed the width of the tread by more than 165 millimeters on each side. Each balustrade shall have a handrail. The handrail shall move in the same direction of the treadway and at the same speed. The tread surface shall be slotted in the direction of travel. Clearances between the treadway and the adjacent skirt guard shall not exceed 5 millimeters, and the total clearance of both sides shall not exceed 6 millimeters. Landings shall be made of anti-slip material. The comb plates are required at each entrance and exit. If anything becomes caught in the comb plate, the moving shall shut down automatically. An emergency stop shall be located near the comb plate or in some obtrusive location. Finally, adequate illumination shall be provided at the comb plates. Section 4.6, titled Energy Conservation, provides requirements for conservation of energy as it relates to lifts. Section 4.6.2.1 indicates that all lifts shall be equipped with necessary sensors and controls to reduce energy usage. For this purpose, the following features shall be included in the lift system. Item A indicates that AC variable voltage and variable frequency drives for the car and door shall be used. B, energy efficient lamps shall be used inside the car and for displays. This would produce a lower power, of course, when we use energy efficient lamps. Some of the lamps that we utilize in modern technology are the LED type of lamps accordingly. The lift shall operate in standby mode during off-peak periods. And finally, item D, the power side of the lift controller and other operating equipment such as the car lights, display lights, and ventilation fans shall be switched off when the lift has been inactive for more than 5 minutes. Section 4.7, titled Inspection and Certification. This section gives us specific requirements regarding the inspection and certification requirements. Specifically, Section 4.7.1 indicates that all new lifts, escalators, and moving walks, after installation, shall be inspected and tested by the authority before these are put into normal services. This is very important, this part of the code, due to the fact that these lifts, escalators, and moving walks transport people to different areas of the buildings. These are electrical and mechanical machines that must be specifically installed, tested, and set up for safe use to convey people from different areas of the buildings. To further indicate what's in this section, it says these shall not be brought into use unless the authority is satisfied that the installations have been carried out as per the provisions of this code and tests indicated that all the safety devices operate satisfactorily. We need to make sure that all the safety features can operate and will operate according to the design and installation. It shall be unlawful to operate any lift, escalator, or moving walk without a current certificate of inspection issued by the authority. Certificates shall not be issued when the conveyance is posted as unsafe pursuant to Section 4.7.7. This section carries out the requirements and the certificate of inspection that must be issued by the authority. When the certificate is issued, all of the safety inspections have been completed and verified that the lifts and escalators and moving walks are safe now for the occupants of the building to utilize accordingly. Section 4.7.3.1 Tests on lifts shall be conducted to ascertain that A, the motor, brake control equipment, and car leveling mechanism function properly. B, the door operation is proper and door locking devices function properly. The car raises and lowers at the rated load. The car achieves at least the rated speed. E, the lift motor can be overloaded up to a minimum of 10% above the rated capacity. F, the safety gear stops the car when the rated load in case of overspeed and or over travel, etc. G, the buffers function properly. And finally, H, the safety gear operate and keeps operation of the lift suspended in case of the lift car is loaded above its maximum capacity. These are the tests on the lifts that need to be conducted for safety functions of lifts. The tests for escalators and moving walks are given in Section 4.7.3.2. And the tests for escalators and moving walks shall be conducted to ascertain that item A, the automatic control device functions properly and brings the escalator to a smooth stop in case of failure of any mechanical part or electrical power. B, the automatic safety protection for overspeed, underspeed, and direction reversal functions properly. C, safety devices function properly and stops the escalator or moving walk when anything is caught between the comb plates and the treads or the skirting and the treads. Section 4.8, titled Operation and Maintenance, gives us specific requirements regarding who is responsible for the operation and maintenance of lifts, escalators, and moving walks. Specifically, we look to Section 4.8.1 that indicates that the owner shall be responsible for the safe operation and maintenance of each lift, escalator, or moving walk installation, and shall cause periodic inspections, tests, and maintenance to be made on such conveyances as required in this section. Moving to Section 4.8.3, in case of lift, periodic examination of wire ropes, components of landing, and car doors door interlocking mechanism, brakes, gears, components of safety gears, guides, rollers, channels, etc., shall be carried out as recommended by the manufacturer. In no case shall the interval between such inspections exceed 6 months. So these two sections indicate that the owner is responsible for the safe operation of all the conveyance equipment. Additionally, the interval between the inspections shall not exceed 6 months. Section 4.8.4, in case of escalators and moving walks, periodic examination of balustrades, handrail, treadway, treadway interconnection, comb plate, speed governor, drives, chains, non-reversal device, brakes, gears, etc., shall be carried out as recommended by the manufacturer. But in no case the interval shall exceed 6 months. This is the same type of requirement that was given to us regarding lifts as well. Again, notice the interval shall not exceed 6 months. Maintenance and operation is key with respect to these mechanical and electrical machines. They must be maintained and must be operated in accordance with the manufacturer's instructions specifically. Section 4.8.6.3 indicates that while the lift is under examination or repairs, suitable steps shall be taken to ensure that the lift is not operated inadvertently by a person in such a manner as may endanger the safety of persons working on the lift. The photo on the right-hand side indicates what we call lockout tag out. This is a method of locking out the control or disconnecting means for electrical motors and electrical equipment, where we actually lock out and tag out by means of the information on the lock who is working on the system. It provides safety to the people that are working on the equipment. This is the end of the presentation. Thank you for your participation.